Virtually everything that happens on land will eventually affect the oceans in one way or another. Nutrients, whether from the wastes and remains of plants and animals or from the excessive fertilization of crops and lawns, toxins like oil that has leaked from parked cars, coarser material like grass clippings, fallen branches, or plastic bags. All may find their way from the land to the sea, carried by the rivers that form a dynamic network flowing to the coast, where they can be pushed offshore and impact the health of our oceans and their inhabitants. The mighty Altamaha River drains some 14,000 square miles in Georgia each year, pouring over 3 trillion gallons of fresh water into the Atlantic Ocean. The oceanic fate of that water, and any contaminants it might contain, was of special concern to the managers of Reef National Marine Sanctuary. Located just 15 miles off the coast of Georgia, and potentially in the path of the Altamaha's discharge, Reef is home to a tremendous diversity of marine invertebrates and fish. Unlike tropical coral reefs, which are made from the skeletons of hard corals, Reef consists of marine and terrestrial sediments like shell fragments, sand, and mud, glued together to form a hard bottom reef that is covered with a dizzying array of sponges, corals, bryozoans, sea squirts, and other sedentary invertebrates. Researchers from the Institute for Coastal Plain Science and the Department of Biology at Georgia Southern University had a unique opportunity to study where dissolved substances and debris go once they leave the Altamaha. In partnership with the Georgia Department of Natural Resources and Reef National Marine Sanctuary, Doctors Gleason and Risa Cohen investigated how materials move offshore during periods of high river discharge and low river discharge. To do this, they released ocean drifters and rhodamine dye at the mouth of the Altamaha River in the fall and spring. Built primarily out of biodegradable materials, the drifters mimicked debris that flows out of the river, broadcasting their location to waiting satellite receivers every 2 hours with inexpensive transmitters. The rhodamine dye, on the other hand, was used to mimic dissolved substances that flow out of the river. Although the dye is spectacularly obvious while being dumped from the boat, after only a few hours it is too dilute to see with the naked eye. So to monitor its dispersal, researchers placed fluorometers which can detect the dye in concentrations as low as 1 part per billion at 5 offshore reefs, including Reef. So what did they learn? For one thing, we now know that there is a connection between the Altamaha River and Reef, a connection that is highly dependent on river discharge. In the spring, when the flow is high, the drifters were carried through the sanctuary and into the Gulf Stream, where they traveled north along the coast. In the fall, the drifters stayed closer to shore and were either brought south by longshore currents if the river flow was low, or sucked up the river if the discharge was really low. As for the rhodamine dye,
each time, it didn't matter whether we released it in the fall or released it in the spring, we would find that both the dye and the drifters would track to the southeast at about 1 to 1.8 kilometers per hour. When we did detect the dye with the fluorometers, so when we detected the dye at Cat Reef in the north, and when we detected it out at Reef on a northeast track, the drifters basically tracked the same way. They would follow the tides in and out. They would have a zigzag pattern, but their path ended up in basically the same place that we detected the dye.
So we learned some really important information from this study. We learned that it matters what season we're talking about. So in the spring, there's a lot more potential for dissolved substances to move from the rivers to offshore habitats. And this is important for several reasons. Dissolved substances are not necessarily a bad thing. So dissolved substances can be pollutants, but also nutrients, which these habitats rely on. So having this delivery is very important. In the fall, we didn't really have as much potential for offshore movement as we did in the spring. The other thing we learned is that these substances move really far. So Gray's Reef is almost 40 kilometers offshore. Cat Reef is almost 50 kilometers from the drop site. So these substances have potential to move really far distances and affect habitats that are very far away from where they're originating.
Knowledge, as they say, is power. And studies like this that improve our knowledge about the movement of riverborne water in the ocean will help biologists at the Gray's Reef National Marine Sanctuary and the Georgia DNR better manage the land's impact on offshore reefs.